So without further ado, we're going to get started with the actual contest. The way this is going to work is that team number 13 is going to come up. And so team 13, while your robot is being set up, can you tell us the meaning of your team name?
So our team number was 13, and we wanted to integrate this into our team name. And frankly, we all love cows. So obviously, it had to be fear of the 13th cow, since we're the 13th team. So hence, triskaidekaphobia is fear of the number 13. So our team name is triskaidekabovophobia, fear of the 13th cow, which means that our team name uses 2 different languages. Also like our robot, which instead of just using Java, which is what the competition is supposed to be in, we use Jython, which is a Python virtual machine implemented in Java. And most of our code is actually written in Python. We have about 3,000 lines of Python and about 1,000 lines of Java.
So what are the benefits of using Jython instead of Java?
It's a much cleaner programming language, and we can program much more quickly, and we don't have to worry about strong typing. And frankly, none of us actually like Java.
So what are we going to see tonight from your robot?
So our robot is going to go around the field and collect balls. The most impressive thing you'll see, hopefully, will be a map that we're generating that you'll see up on the Bachline. It'll generate a map based on what it sees and its distance and range and angle measurements of various features. It uses a Kalman filter to combine the uncertainties of various measurements to produce a map. And you'll see little pretty error bars showing what the standard deviations are of the various different features it sees.
So one thing that I didn't really talk about is that. So actually, we're ready to go. So we're going to go ahead and get started with the round. What does your robot do when it starts up?
When it starts just wandering. And mostly, it'll just wander until it sees a ball. Whenever it sees a ball, it'll try to pick up the ball.
Is it seeing a ball right now?
Yes, it is. And it's picked up the ball, in fact.
Now, what's it doing right now? Is it confused about which ball it's going to go for?
It looks like it's trying to align itself to, yes, there it is. It's going for a second ball, and it has a second ball. And it's going for the third one.
So how many balls can you actually hold in your robot?
2 or 3. It looks like that was probably part of the problem with that. But now, as you can see, it's wandering around. It'll deposit them as soon as it sees a gate.
Now, is it still looking for red balls at this point? Is that what it's trying to do with that ball in front?
Quite possibly, but as you can see, it was able to figure out that it got stuck and backed up and is going around.
Now, showing up on the Bach client screen up there, we see a bunch of green and blue dots. Can you explain what those are?
So the green marks are the barcodes that you see around the playing field. The blue marks are the tick marks. We use these as our primary features for constructing our map. And you can see error bars based on the various different uncertainties.
So what's going on with your robot right now?
So it sounds like the roller is turning in a different direction. We had a lot of trouble earlier with the roller alignment. It was very noisy. We made it much quieter, but apparently it's noisy now at the moment.
Is it trying to align itself to the ball that it is in front of?
It should be. I see that one of the wheels is turning, but the robot isn't actually moving. It might be slipping on the carpet. Oh, it's wedged on top of the ball?
Help it!
So is your robot going to realize that it's been in the same place for a while?
It is. It's trying to move, as you can see. But, well, actually, you can't. One of the wheels is spinning, and it's trying to get out. But if the ball got stuck underneath it, I'm not sure. One of the wheels might be off the ground. I don't know.
Does your robot have any sort of violent break-free behavior that we might see?
Well, it's supposed to, but at the moment, that's what it's trying to do. But it apparently is not succeeding.
So while we see what the robot, it seems to be moving slightly. So while we see what the robot ends up doing, so tell us a little more about what we see up there. Can you match any of those parts of the playing field to what the audience may be seeing?
So the little yellow circle on the right is our starting position. And we started over there, and then we moved around, and you can match up the barcodes to the playing field. So those two barcodes on the bottom are like those two barcodes right there. And then the other barcodes, sorry, I think I got my orientation mixed up. I think those barcodes there on the bottom are down, no, that side.
Okay, it seems like you guys have decided to end the round because your robot is stuck. Although, if we have time at the end, you may get to see Team 13 go again. So how many points for 13? So we have 4 possession points for Team 13. Both of them? Two teams that are up have a couple of issues going on with their robot, so we're going to try to have them come up as soon as possible. But in the meantime, I'd like to talk a little bit about how the playing field is set up to help teams do their scoring and keep track of where they've been. So as you've noticed, around the playing field are these green barcodes, green and black barcodes that contain 5 bits each. They actually only contain 4 bits of information. There are always an odd number of green boxes in each barcode. And this helps teams to determine if they've correctly read a barcode, because if they read an even number of green squares, they know that they have not read the barcode correctly. The way the barcodes are set up on the playing field, you can always see another barcode from a particular barcode, which we call line of sight connectedness. This allows teams to create not a full metrical map, as you saw being created by Team 13, but a map that just consists of, if I'm at this particular barcode, what other barcodes can I see? So we had several teams attempt to create these maps in varying levels of functionality. But what this allows you to do is that if you're seeing a barcode and you see the power ball and you know that the power goal was near another barcode, you'll notice that all the goals are marked by barcodes. Then you can plan a map through your barcode graph and find a fast way to take something from one place to another place. Another way that teams can take advantage of these barcodes in a simpler sense is that they can use these barcodes to tell where they've already been, to create more efficient wandering algorithms. And the other thing that these are helpful for, which you will hopefully get to see a little later tonight, is that since teams get points for spreading out their balls between different goals, the barcodes that are near the goals help a team identify whether they've already scored in a particular goal or not, and if they should try to go to the next one instead. Wait, no, isn't that 5? Okay.